my class yesterday.
Okay, so does anyone have any questions on 7.1 worksheet 1? This is for 033. Why is it 0.033? Meaning Cindy. Nice. Okay. All right, then let's start on number 2. So we are on page 616. No worries. We'll start here and we can go back to it if we need to. This is the 133 worksheet for me, meaning Eric. And we're looking at the normal curve. And so let's just take 5 minutes and you all see if you can't figure out these first 2 questions, focusing on the relationship between the mean and the shape of the graph and the standard deviation in the shape of the graph. Of course, pay close attention to this word largest and smallest, right? Because it's the opposite if we change that. So let's do that. 5 minutes on that. So the timer for 5 minutes. And if you get done sooner, you could just be like, hey, I'm done. That works too. You all can just see the worksheet, right?
Yeah.
Okay. How'd you do? Did y'all get it or need more time?
I got B, but I'm stuck on A.
All right. So where is the mean on the normal curve?
The middle.
You got it. So C's mean is here. So I'll say mu C. B's mean is here. So I'll do mu B. And A's mean is here. So I'll do mu A. Now this graph is a little misleading because this is the x-axis and somewhere is the y-axis. Probably over here. So note that this is 0 and this is infinity going this way. So which of these numbers is going to be the largest?
C.
You got it. Okay, so then what's the answer to question 1A?
A.
Yeah, nice, right? Okay, I tricked you all. And why? It's closest to 0. So for the mean, we're just looking at where is it on this number line. Now, which one has the largest standard deviation? What'd y'all say for that?
B,
Yep. Why?
because the curve is short and wide.
Nailed it. Short/wide curve. I like those descriptions. The other thing you could say is it's the most spread out. Most spread, because there's more points far from the mean than close to the mean. Okay, good. Does everyone feel good about that? That's a conceptual understanding of the shape of the normal curve and its relationship to the mean and the standard deviation. So on the midterm, when you were writing the interpretation of the mean and the standard deviation, this is the picture you would have in your head. So larger mean or larger standard deviations meant the normal curve would look like B, and smaller standard deviations, it would look like A. And remember that script that you have would only apply if the data set is normally distributed. Hey, that's the end of that. Okay. How do you all feel about this one? You think you can just do it with 0 help, or do you need a little coaching to get you going? This is often.
I'll need the coaching.
Okay. So first, let me ask you a question. What is the relationship between, or like, what is area also the same as? Like, what information do we get from area? And it's totally cool if you have no idea.
They're probably frantically looking in their notes.
I'll pause. I'll put a ponytail in because this hair is getting like a pain.
So you guys, I'll give you a clue. Remember, write it on the first page of the notes. Chapter 6, we called it one thing, but in chapter 7, we call it something different. So what did we call it in chapter 6?
Here's a good hint. What does the area of the bars add up to? That was 1. Oh, wait. Shade the region that corresponds to the probability of 4 or 5 tails. And you all did this, right? And then here it says shade the region that corresponds to the probability between 20 and 25. I'm shading area, right?
Yep, then it says the area under
Oh,
that curve. Yeah.
So the curve is 1. All the bars sum up to 1. This. I'm going to make you all say it. Someone say it or type it. What is the area the same as? Oh, you're giving me the answer. Nice. Nice, Reagan. I want to know, what does area mean, generally speaking? It's the same as what concept? Love it. Love it. The area of a rectangle is length times width. How about the area under the curve? Or does anyone remember the formula for the area under the curve?
Yeah,
there it is, Sean. That's it. That's it. That's what I'm looking for. Here's the area under the curve, by the way. Although you have to integrate this from like whatever you want.
Eric, we looked at that and I said, you guys, we are not even, we're not going here.
This-
Sorry.
Yes.
Eric
No.
probably would have explained it, but I just like
No.
looked at it and said, no.
I mean, there's crazies. There's some things in there you all recognize, right? Anyone know what mu means?
We knew mu.
Yeah, that's the mean. Well, I can't even write it. Here's the standard. Well, here's the variance. This is just pi from the circle, right? 3.14. This is Euler's number, that 2.78, blah, blah, blah. What this is it's the equation that if you typed this in with numbers for mu and sigma, you'd get these normal curve graphs. You'd get this graph. So that's the equation for the graph. You don't need to know it at all. When I took this like a calculus-based version of this class, that's how we calculated the probabilities, as we use that.
I made sure nobody was going up into calculus and there was not one.
Yes, you don't need to know
Believe it
that
or
thing at
not.
all. I'm shocked. Calc is fun, you all. It's when math gets real. Okay, so that's a key concept here that you need to recognize, is that the area, this area under the curve, is a probability. So when I say what's the probability of randomly selecting a value that's greater than 91, I'm really saying how much area is there under the curve? That's 0.06407. So, Reagan, your answer, 1 minus, is the answer to C. Okay, let's pause. How's everyone doing with A? Okay, good. Now, you learned a bunch of stuff about this normal curve. You know the entire area is equal to 1. So if I shaded the whole thing, that's 1. What do you know about the area below the mean? How much area is here?
Come on, guys, talk. You know it.
Or type. There we go. I just got to have chat up. 40. Now, go ahead.
No, I'm going to say, you say it, Eric.
Remember the numbers that probability can be? A number between 0 and 1? That same thing applies here, that the value, the area under the curve is a number between 0 and 1. So, Reagan, you got it. It's 50% or 0.5 is below. How much area is above? You're right, 0.5. I got impatient. Shame on me. Now, quick question. How far apart are these two numbers? 80 and 91.
11.
11. How'd you get that?
91 minus 80.
Okay, good. So 91 minus 80 is equal to 11. So that means this distance is 11. Now, if I go 11 below the mean, what am I going to get? 80 minus 11. I don't know. My calculator is going to say 69. Y'all with me on that? Okay. How much area is there going to be below 69? Like, what is this area equal to?
The same that's above 91.
Good. How did you know that?
Cindy told me yesterday.
Okay.
So what did we
good.
say the reason was, Reagan? Remember? We said there was a reason.
Because they're symmetrical or whatever.
Nailed it. Yes. Okay, so that's everything you need to know to solve this, to fill out all these answers. You need to know that the entire area is 1, half is below the mean, half is above the mean. We know this piece of area, it was 11 above the mean, so if we go 11 below the mean, the area will be the same. You should be able to figure out how much area is in here. There's a connection between this area and this area. And then because it's symmetric, meaning the area above and below are equal, you should also know this area once you figure it out. And I mean, it's the same idea. There's a connection between this number and this number. So I'm gonna go ahead, talk to me.
Sorry, to find the yellow and the pink, you do 0.5 minus 0.06407. That, okay.
Have you been to the weight room this morning? Sounds like
No, I went on a run.
that's
with
the
the dog.
same thing.
Oh,
You are on, no, I don't know. That's like a ridiculous question.
Just curious, Eric, if she would have said on the midterm to explain because Cindy said so, what would you have said to that?
-1.
You guys, I'm not the scapegoat, I guess. I'm not good enough, so we had to
Sorry.
say that symmetrical.
You just have to say, what did Cindy say? Because Cindy said it's symmetrical. And I'd be like, yeah, that works. Okay, so let's take 5 minutes and see how much of this you can get. We've essentially answered it all, but you need to connect the probability notation and the words with the area up above and all that mess. So let me give you 5 minutes to try it. If you get stumped, scream, I'm stumped. Set a timer for 5 minutes.
You guys remember you can use your page 266 if you get stuck writing your probability notation. Some people were getting stuck with that yesterday. So you can use your exam notepad page 266. These are pretty simple. I think you'll be fine. I can't say easy or simple. Never mind.
Once you've worked through it and catch all the connections, I agree with you, Cindy. It gets less intimidating. I teach this in the quantitative reasoning class, and if students are there on the day we talk through it and practice it, they do fine. But if you have never seen this, like, it's strange. Okay, how we doing? What y'all do for B?
Are we doing B?
Yeah, what'd you do for B?
Okay, I got 0.5 because it's like greater than 80 is the half, the upper half.
Nailed it. So it's this entire half. Good. How about the rest of you? Maybe I should check. I want, so this is, I want you all to
Same.
be, go ahead.
I got 0.5.
Nice. I just want to make sure, like, I don't want to pause for hours if, like, I just want to make sure I'm not wasting your all's time. Okay. How did you do for C? It's a tricky one. Symbolically, it looks like this. If I were to shade the area, sorry, the area that this is asking for is all of this. Do y'all agree with me on that? Y'all feel good about that? Okay, nice. Two ways we could do it. Yeah, Taylor, love it. Awesome.
Eric, we actually had 3 ways that they gave me yesterday. It was
Ooh.
awesome.
Nice.
So you
One
give the
by-
2.
So there's,
I'll give you the 3rd way.
okay, so there's that one. There's
So-
0.5 plus, oh. Well, there's this bit plus 0.5. And what's the third one?
So you did the 1 minus.
1 minus.
And then you did the 0.5 plus, or you could just add up the 3 separate sections.
Love it.
And I said, you use whatever your brain is telling you.
Yeah, so, and the point of this question for you all is to do that, to get all the connections of the normal curve and how all the areas and probabilities relate to each other, and the symmetry, and it's kind of like a little puzzle. Do you remember those like logic things you did in grade school where it was like the box and it's like so and so did this and so did that, and some of these did not do that or something, and then you filled it all in, and this is like that. Okay, let's keep going. X is less than 69. Did you all get the same answer as A?
Yes.
I've now got too much. Excellent. 0.06407. Because it's just this piece. Now I've got way too much up here, so we'll erase a few things, shall we? Okay, good. Then the X is between 61 and 91. Ooh. By the way, if we had known the standard deviation, which we didn't, right? It didn't tell us. We could have used StatCrunch and the normal calculator to calculate these, but we were only told the mean. So we don't know We can't use that calculator. So we have to use our knowledge of the one piece of area we were given. By the way, if I'd asked you what's the probability that it's less than 85, it's impossible to answer because we don't know the standard deviation and we don't know any other connections of areas. So these problems are very contrived in that we have to give you, there's only so many questions we can ask that you can answer. And it's all about, hey, do you get the symmetry? What'd you all say for this one? 1 minus 2 times that, or 2 times 0.5 times this, or
I did in parentheses 0.5 minus the 0.06 whatever, and then times 2.
love it.
Okay.
So 0.5 minus 0.0640. Let me try my handwriting a little better. Times 7. That is one of these little areas. That's this area right here. So if you're wondering why that was multiplied by 2, it's because we need the area above the mean and below the mean. So one of them is this piece and the other one is that piece. And I don't know what that answer is. So 87, 18, 6. Okay. And let's see, probability that X is between 69 and 80. Note that's the same as this area up here, so it's just one of these. Okay, how you feeling? Yay, hearts. Ooh, look at these emojis. Love it. 0.4359.3. Okay, you ready for a trick question? What's the probability that X equals 80?
Don't let them trick you guys.
I'm trying really hard.
I know.
It's not possible.
So
Right.
what's the
It's
area?
0.
0. Good. The reason, by the way, is because there's an infinite amount of possibilities for the number that X could equal. That's the point of continuous, right? There's an infinite amount of options. So we're picking one thing and dividing it by infinity. Like if you think about how this probability is calculated, it's this, which is 0. If your divisor is infinitely big, it's nothing. So and it's because Cindy said so. Yes, yes. So keep track of that. You're going to see in the calculators, like you might see places, if I put an equal to sign here, that's meaningless, right? But compare that to what you did on the midterm in chapter 6. There it was meaningful. Like when you did the binomial stuff, let's see if I can find one. Yeah, here, like when, like this one, we're like, hey, what's the probability that X is exactly equal to 12? That's a real probability because this is discrete. 12 is one of the outcomes in the list of possible outcomes. In fact, the outcomes are 0 to 18. So that's the big distinction that you got to make now, is that when we're talking about a variable that is continuous, we're looking at an infinite amount of possibilities for what those numbers could be for X. And so when we're talking about a probability, it's always between two numbers, either a number and above or a number and below or between two, and it's an amount of area. It is never equal to a specific thing. Okay. Quick reminder. Did anyone remember this thing? Was it on the midterm? I don't think this was.
I don't know. I haven't seen it.
Oh, I should have sent you the midterm, Cindy. I'm sorry.
No, it definitely wasn't.
This graph was not on the midterm. Yeah. Shocking. I'm surprised I didn't do that. What we're doing now is the same thing you did here. The difference is we are not calculating areas based off of these specific standard deviations. We're in between them.
Right.
Okay, so this is still true and this is still valid. So that leads us to this question on this third page. Where are you, friend? Here we are, where you are to draw in the picture with the parameters labeled. Well, that's the exact same thing. No, it's not. Well, you don't know the standard deviation. You do know the standard deviation. Yes. So this part is the same thing that you did in that chapter back on the midterm. So do that and then draw in the picture. I will write it here in symbols. Draw in this picture of it takes 45 or more to drive to work. That's technically X is greater than or equal to 45 minutes. And you're told that this is equal to 0.0743. So I want you to draw the empirical rule on this, then plug this in here and do the thing that Cindy told you to do of how to interpret area. There's two of them. We'll do 5 minutes for real. And I'll try really hard not to talk for 5 minutes. Set a timer for 5 minutes.
Eric, I kind of talked to him about, and I want to verify, in this continuous data, the greater than symbol and the greater than and equals to symbol, aren't they considered to be the same? Because, well, like when we go to StatCrunch, I think they only have the greater than or equal to symbol. They
Right.
won't have just the greater than symbol because of that thing right there.
So in one of my grad classes, there's a weird little thing you do that it does actually matter a little tiny bit. But for us, it doesn't matter at all. They're the same thing.
Okay.
Yes, that agreed.
I just wanted them, when we get to 7.2 tomorrow, to realize that whole, it did matter with discrete data, but when we do this,
Right.
they're not gonna even have the option to pick a greater than. It'll be greater than or equal to.
Yeah, these are the same thing.
Okay, I just wanted to make sure I was correct there.
Yep, you're right. I agree. How'd we do? Need more time or ready to roll? What's the middle number?
32.
Nailed it. I should have done our reading thing, right? So a large business surveys on how long it takes to travel to work in the morning. Hooray. So the morning commute is X, has a mean of 32 minutes and a standard deviation of 9 minutes. Do y'all get why this is continuous data? The measurement of time, right? And I suppose if your boss is a super strict kind of person, if you're a second late, you might, get your pay docked or something. I don't know. That seems strange, but maybe. So you added 9 for the upper values, you subtracted 9. Oh no, 23. For the lower values, 14. 5. And so this part down here, these are minutes. And then we're going to be working with area over here. Note that like the y-axis is somewhere over here. Talk to me, Reagan.
When we like do these on our, like, are we supposed to label them minutes and stuff like that, or do you not really care?
I don't really care. It's okay. I'm
Okay.
just putting it in. So notice our 45 here is a number somewhere between 1 and 2 standard deviations above the mean. So quick question, would it be unusual to take 45 minutes to get to work? That's just a midterm question. And I'm just going to keep reminding you of midterm type material because the final will have some midterm type material on it. So is it unusual to take 45 minutes to get to work? Or is it too soon? Oh, wait, here's a chat. Yes, why is it unusual? Okay, that's the key. Is it more than 2 standard deviations away? So let's evaluate that. This is +1 standard deviations. This is +2. 45 is here. Is 45 above 2 standard deviations?
No.
Nice. So from a standard deviation point of view, no, it's not. It's less than 2, so it's not unusual. If we thought about area, it has to be less than 0.05, or a probability less than 0.05, which it's 7.43% chance that 45 above 45. So it's actually, you had the right thinking, Taylor, in terms of how to determine if it's unusual. Just make sure you're checking, is it above the 2 standard deviations or less than the area probability. Okay, what were the 2 sentences you wrote? Or were you totally stuck on them?
For the proportion one, I put 7.43% of all commutes are more than 45 minutes.
Love it. The key here with this proportion thing, I'll put in a word that I don't know if you said it or not. It's okay that you didn't say it because you don't have to. It's implied. Let's use purple. Of all. So the proportion one is like looking at the forest and seeing all the trees in the forest. 7.43% of all commutes are more than 45 minutes. So you're looking at everyone and saying this % of all people meet this particular criteria. The other one, anyone know the other one? Hint, you're looking at the trees in the forest. Let's see, how about I not just make it up off the top of my head? How about I follow it? So the second one is the probability of randomly selecting one thing from the population, and they have that characteristic. So for this one, you're saying, oh, come on now. You're saying the probability of randomly selecting a commuter that takes more than 45 minutes, that takes more than, that says, to get to work, is, and then whether you write it as a decimal, a percent, or a fraction is up to you, is that. So think selecting one. That's the difference between the two interpretations. How are we doing? Yay. Let me give you, I don't know if this is helpful or not. This stuff is going to become a really tiny, tiny piece of a big process in chapters 9, 10, and 11. So what we're doing is trying to help you understand this connection between the area under a normal curve, the probability, and what that tells us conceptually, you know, like in the context of the problem. And then we're going to use this with a z-critical score, and that's like the only thing we need is like, do you know that this area is the chance of something happening? And it becomes this one little piece in a 6-step process for the hypothesis test. You are going to eat, sleep, and drink this until it becomes like speaking English a little later. So, you know, take your time to try to really take it in and enjoy it. And then know that it's a small portion of a more interesting thing. So let's go to 7.3 then. Kind of interesting that we're doing this out of order. I get why, but. Okay, so we're going to learn in chapter 8 that determining. How about you just don't these out? Sorry. So we're going to learn in chapter 8 that one of the conditions, this is number, let me just look at what it actually, I think it's number 2, and you all do number 1 with Cindy. They're the same thing, and it's going to take like 2 seconds. Let me just make sure I got the right one. Seven, 3, number 2. So this is 7.3, number 2. This is for Eric. We go back and do 7.1 as well. 133. So it becomes really important that knowing if a population is normally distributed. So think back to lesson 1, to unit 1.1, the very first day of class. We talked about the process of doing a study in statistics, where we have a question, and from that question, we define the population. From that population, we draw a sample. We collect data from the sample to create descriptive statistics. We then do some analysis of that data to do inferential statistics to then make a claim about the population. Well, in order for our analysis In order for our claim from the sample to the population to work, to be valid, we have to know things about the population. And one super useful thing is for a population itself to be normally distributed. So what that means is we've got a data set. In this case, it's student loans, the amount of money a student borrows, the amount of money a student has as student loans. If that's normally distributed as a population, then when we collect a sample, we can make inferences. We can make an inference about the mean amount of student loans that all students take. So one of the ways we do that is we look at what's called a normal probability plot. Took me a second to remember the name of this. So the normal probability plot. That's what this thing is. Now you need to be careful. This looks a lot like a scatter plot of two variables from which we wrote a regression equation like we did back in chapter 4. You could also be confused with a residual plot, which is the graph of the difference between the data values and the regression equation that we found back in chapter 4, right? And remember, with the residual, just a second, sweetheart. Just a second. With the residual plot, we looked at, was that plot randomly dispersed? If it was, then the regression equation we found was a valid and useful tool. If it wasn't randomly dispersed, then it was garbage. We shouldn't have done anything. So your job for the rest of this class, like till the end, until the final exam and all that, is to keep track of what kind of graph are you seeing? Is it a normal probability plot? Is it just a scatter plot? Or is it a residual plot? Because each of those graphs we use in a different way, and we have information from it that we need slightly differently. So for a normal probability plot, we're looking at kind of like what we did with the scatter plot. Does it look approximately linear? So are these data values essentially related to this line, or does it look like it's something else? That's the language I'm looking for. It's either, yes, the normal probability plot looks approximately linear. That means it is reasonable to assume the sample came from a normal population. Or no, the normal probability plot does not look approximately linear. Thus, the population is not approximately normal. Whew, that's a lot, right? So this one, hopefully you see, yeah, that's pretty clearly not a line. Do you all feel that you could note that even before I drew this? Could you look at that and say, nope, that doesn't look approximately linear? Okay, good, good. It takes some practice of seeing a bunch. So we'll just say no. And I'm looking for this specific language. I want you to write, in fact, maybe just put this in your reference sheet. I want you to identify the type of graph. And that is the normal probability plot. That's the type of graph. In other words, you're telling me you recognize this is not a scatter plot of two variables. It's not a residual plot. It's actually the normal probability plot. And then you know how to read it. No, the normal probability plot is not, that's the thing we're looking for, approximately, come on, approximately linear. What does that mean? You don't have to write this, but let's just make that clear. It means the population is not approximately normal. And what does that mean? Well, you're going to find out later. I'll tell you now, it means we can't do a particular test on it. There are other tests. You're not going to learn them. Go get your undergraduate in statistics or your graduate degree in statistics. You'll learn all that. It's awesome. You should do it. Okay, what do you all think about number 2? Yeah, that looks approximately linear. So the question here, is it reasonable to treat the sample as coming from an approximately normal population? Yes, the normal probability plot looks approximately linear. So when I grade this, I am more interested not in whether you can correctly identify that it's approximately linear or not approximately linear. It's that you know that's what you're looking for. Does that make sense? And I'll say, thus, in accordance with the prophecy. Okay, does that make sense, y'all? I mean, don't actually write this. There was no prophecy that credit card debt is approximately normal as a population. Prove it to me. Go here and answer these two questions. So this is the one for Cindy. This is worksheet 7-1. This is Cindy's for 033 class. Write the correct answer for these, or at least the correct reasoning. It's okay if you don't get the correct approximate linear or not. I'll give you 5 minutes. Set a timer for 5 minutes. Okay, how we doing, y'all? I feel like that was probably more than enough time. What'd y'all say for number 1?
Yes, the normal probability looks approximately linear.
Love it. So the most important part is that the normal probability plot looks approximately linear. Yes, that's the key. Excellent. And I agree, this does look linear. Some people might say, oh, look, it does, you could think it does something like that. But think back to the scatter plot. They're all pretty close. You could think about what the R squared value might be if we were to do a simple linear regression. We're not going to really do that because the y-axis is the normal quartile plot. And then the x-axis is the actual data values. Okay, what did you all say for number 2?
No,
Because,
the probability plot is not linear.
yep, that's it. So I am looking for one of these 2 answers, even if you were wrong, even if you said, yes, the normal probability plot looks approximately linear, I would be tempted to give you full credit. I would at least give you most of the points. Like if this were a 3-question problem, I'd do -1 if you said yes, because I think you should be able to recognize that's not linear. But if it's like, I don't know, you could argue with me on that. My point is, what's most important to me is that you know what kind of graph it is. So this probability plot, and you know that you're looking for it to be either linear or not linear. Wow, we did everything. I am curious of one thing. When you think about the exam, you think about the sample midterm, how similar do you feel they were?
I felt like the sample midterm was a good, like they weren't exactly the same, obviously, they can't be, but it was a very good, like, representation of what the midterm would be.
I agree.
I just want to point that out because they were like really, really similar. I want to point that out as you think about prepping for the final exam. Like I mean, I hate to do this, but you're capable of doing this because you have the final. Here's the sample midterm, the first question. Oh, wait, hang on. Let me make sure I'm sharing the screen properly. And then here is the midterm. I'm wanting, I'm like, because I want to make sure we all feel like you were able to be prepared. So here's the first question and the other first question. Different graphs, right? Histogram, which is more important to me than a time series graph. And then, you know, what type is it? Well, this one asked about shape, and it asked you to read some information from the graph and then asked you some probabilities from a histogram. So this one thing about this is you got jumped straight to chapter 5 in question 1E. Okay, no worries, Peg. Question 2 didn't appear on the exam at all. Whoops. Question 4 from the sample is almost exactly the same question as the midterm. I mean, it's like there's almost no difference. And then question 5, same thing. Find the same stuff, calculate some fences. What's the shape? Though I didn't ask you about outliers. What's the z-score? that, and then the next question, this one got skipped, right? That wasn't on there. Here, this one, these are this essentially the same thing, except the way it's set up. It looks a little different. I'm like, what's the equation? What's the correlation coefficient? All that. And then, yeah, the very end, this very last question, number 10, is the same as number 16. Find these pieces. The mean got moved to the very last question, and then find some probabilities. Shroop, shroop, based off of what you wrote down from here up on this one. So I'm not saying this to like make anyone feel like you should have done really well on the actual midterm because they were so similar. I'm wanting to point out that if you were able to do this without help, then you should have been able to do the midterm. And if you weren't able to do the midterm, it's either because you didn't really understand this without help. That's one thing. Or the fear of the midterm and the testing environment and all that mess got in the way and it clouded what you actually know, which is what I don't want to happen. And if that did happen to anyone, it's something to think about for the final. How can we help take away the fear and the whatever that gets on there? So I don't know if anyone has anything you want to say. Go ahead, Cindy. Oh, Reagan, sorry.
For number 7, I was just so confused because it said like what you had like that we were supposed to use StatCrunch for that one, and I don't know if I completely messed up, but I did it without StatCrunch. Like I don't know if I did the wrong things, but
Where
I
did
was
it
like,
say you
So
had
Eric,
used StatCrunch?
evidently the students were talking last night and they said when they used StatCrunch, the decimals didn't line up.
Oh,
Like it wasn't the same.
that's this one, number 4.
oh
Yeah, oh yeah.
for
It was
number 4, yeah.
Yeah. Yes. There were a few subtle differences between well, that was actually the only difference. Yes. So far I haven't graded a lot, but so far it hasn't made a problem for anyone. The one thing that messed up is this question here compared to what was actually on what was in the data set. This would have messed everyone up, but so far everyone's done it right. So I'm going to have to evaluate at the end after I grade everyone if this is a problem.
That one was a problem for me, I think. I'm not sure.
Because you get a negative number for Y.
Yeah,
right?
and
Which
and I was like, I did it over and over, and I was like, this is what it is. Like, it just doesn't make sense. And yeah, but
I
It's
know
because-
Will was talking last night, Eric, and he said the same thing, that that question really confused him because of that. I think it probably was that question.
Yeah, and it's yes, it's because these were all multiplied by 100 in the data set that was uploaded in StatCrunch. So it was 25, 25.9, 28.8, which then meant if this number to match the data, this should have been converted to a 26.8.
oh yeah, no, didn't do that.
Or these or the data set should have been changed to this. Now that's unfair because that's my fault that what I put in was these numbers multiplied by 100 as opposed to the actual data set. So once I've graded it, I'll look through. Once I know what everyone's done, I'll see what I need to do with that problem.
But yeah, with number 7, I saw that it was like a thing on the StatCrunch, like on the sheet that it was like the whatever for number 7. I was like, oh crap, I didn't even use StatCrunch for that one, but I think that's okay, right?
Yeah, you didn't actually need it, but it was a data set, so I had to give it to you as a data set so that I wasn't like.
Okay, yeah, because after I was like 7, I'm already past 7. I didn't even use it. Oh no.
No, you didn't need it because I guess I should have put this one in, but this isn't actually a data set. It was just in there. If I'd asked you to calculate the mean on number 7, then you would have needed the data set. but I had you calculate a grouped data set for a mean back up here, so I didn't need you to do it again. Although you would have had to use the custom calculator down below as opposed to this one. So yes, I agree with you all that this problem is problematic because the data set that you were given is different than what was on the exam. Like I said, so far, everyone has just plugged in the data value, got out the Y value, and then told me what that meant, even though it didn't make any sense. And that was like, for me, that's fine. I just want to know that you know how to take an X value, plug it into an equation, and calculate something with it, even if it didn't make any sense. But I'm going to look at what each of you did. Hopefully you didn't leave it blank, and make a decision of, should I just throw this question out, or what? And once I've graded all, I'd be happy to talk to everyone individually about how you feel about that. Anything else you all wanted to mention or say or talk about on the exam? The other reason I wanted to put these side by side is to highlight what we're doing in class here. And where I'm like, hey, go take 5 minutes and do this question and get the answer, right? That is you studying for this exam, because if you can do this without me helping you, you're ready, you know it. But if you have to wait for me to tell you the answer, we don't know if you know it or not, because when exam time comes, it's just you. So I'm wanting to highlight that and encourage you to, if you're not doing these by yourselves before I give the answers, change that. That is going to be the best way to learn the material. Just writing down the answer isn't particularly helpful. That's a great question, Taylor. How much is actually ungraded? If you turned in the work, you should be good. If you haven't turned in the work, then yes, you're failing. is how that goes. Does that make sense? Okay. I'm going to get this exam graded, and then I'll put in grades for all that other stuff. I thought I had most everything in. I guess I haven't. I keep forgetting to grade the projects. That's the one that I need to get to. Okay. We have an hour of class time left. We could talk about 7-2, but that takes maybe what you would be doing. What is today? Wednesday? Tomorrow night. So I don't want to take that away. We could point out that not only is there a sample exam that you grade, there's also a monster review that has all practice questions that then there's an answer key at the end. So the sample midterm exam you turn in for a grade, and then there's this exam review that you could have done for extra practice, and then there's an answer key at the end to check your work. So I want to make sure that, I think I forgot to mention that in terms of the midterm, I want to make sure you understand that for the final exam, there is plenty of practice problems where you can check to see if you got it right. And maybe this time around, maybe we just do this one together where there's an answer key and force you to do the sample final exam with zero help from anyone. I don't know. We'll cross that bridge when we get there. I got to see how their grades look from the actual midterm to see, is my structure for how we do these worksheets helping you, or is it hurting you? So, Cindy, what should I?
You might, there are a lot of people that are behind on my stat lab. So I don't know if you want to just like let them have time to maybe work on my stat lab and answer questions if they have questions. Because what I did, Eric, is I went in and I changed their My Stat Lab, any assignment through 6.2 that they had not started, I changed to a 0. I mean, they can still go back and work on them, but there were a lot of people who had only started like maybe 2 assignments. And
Mm,
so obviously that dropped their grade from 100% down to like a 12%.
yikes.
So there is a lot of work that needs to be done for some people in my stat lab. So that's always an option that you could do.
I like that. I think that's a great idea. How do you all feel in here? I mean, let's do that. So I'm gonna.
Oh, yeah, so
Oh,
it looks like Kayla has a question on the
oh yeah.
7.1, the one that I assigned for them.
Let's do it. 7.1, number 1, 4B. Ah. So, let me look at what we said here. I asked what I thought was a trick question. I said, hey, what's the probability that the thing is exactly 80? Yeah, Kayla, you got it. Any number, anytime we ask for it to be equal, exactly equal to a number, there's zero chance of that happening. Yeah. Yeah, that's very mathy language. Plus, there should be a space right here. Cool, good. Let's see. Taylor, I'm so with you about going over the answers. I'm the only thing I'm fearful of with going over the answers, because I can't see if you've actually completed the worksheet, is that there's a group of students that might be waiting for the answers to be shown to fill them in. And if I'm allowing that to happen, I'm setting people up for failure, right? So one thing we could do is I could make the due date, I could make a fast, hard due date for the sample final exam. And everyone has to turn it in for credit at that particular time. Like right now it's listed to be the 11th, and that's December 11th, and that's the one I grade. And then in class, we go over the answers for all the answers after it's already turned in, as like this pressure of like, hey, you've got to do this yourself to see if you're actually ready for the exam. And we could talk about that and think about that. Again, I need to grade all the midterms and see, maybe everyone crushed it and I don't have to worry about it at all. And my strategy here is working. Okay, so I am going to then, I really like Cindy's idea. Say, why don't you take the rest of the next 40 minutes and work on Stat Lab, and I will just be here as a resource for like you get stuck on a question and we can share screens and look at it together and talk through it and help you get it right.